Hey guys, and welcome back. Today we're going to be talking about using linear models in order to predict things about our data sets. So again, our learning target, and this is going to wrap up our learning target for the week, is to construct and explain scatter plots. Again, this is going to be more on the explaining side because we're going to use some algebra. We're going to create some y equals mx plus b's and use that equation in order to predict things and explain what they mean. So our success criteria today is to draw a line of best fit. Line of best fit. We're going to talk about what that means, best fit. We're also going to make predictions about interpolated and extrapolated points. Interpolated means a prediction amongst the points, and extrapolated means outside the points. So are you making a future prediction, or are you making a prediction about something that is within the data that isn't quite a data point? So let's take a look at our key idea here. It says when two sets of data have a positive or negative linear association, you can use a special line called a trend line to show the association more clearly. Trend line is a synonym for line of best fit. Okay, so if I ask for a line of best fit or a trend line, I'm talking about the same thing. A trend line on a scatter plot drawn near the points that approximate the association between the data set. Now, I do have two very important pieces of information here. It says the trend line should be as close as possible to each data point, and there should be about as many points above the trend line as below it. So one thing I do not want to see you guys do is something like this and split the points in half, where I have about the same amount of points over here and the same amount of points over here. That's not what I'm talking about. The trend line should actually follow where the points are. So it's like the line that we've been drawing, saying it's the path that the points are following. We just want to draw it in a way that there is around the same number of points above as below. So I see a couple on the line that I drew. I also see 1, 2, 3, 4, 5, 6, 7 below. 1, 2, 3, 4, 5, 6 above, and then again those two that are on the line. So six above, 7 below. That's pretty close to being even on the top and the bottom. And the trend line that I drew follows where the points are going. So that's how we're going to be drawing our trend lines. The first example says, which of the lines shown are reasonable trend lines for the scatter plot, and explain your reasoning. Now, when I look at these different colored lines, I do see one that is completely unreasonable, and that's this red line. Okay, this is unreasonable. Mainly because it's what I was talking about before, where it splits the points evenly with the same amount above and below, but you get this line that's not actually following any of the points. In fact, I see 2 points that line has on it, but those seem like they're outliers. Those points aren't following along the same path that the other points are following along. So I wouldn't use those 2 points in order to create a trend line. That trend line doesn't look like it's showing the path that the points are following. Now, the green line is definitely a reasonable one, and so is the purple one, but I would say the green one is the most reasonable line, because with the purple, we get what I like to call a bow tie effect. Okay, so I see some points below over here, I see some points above, but the ones that are below are really far to the left, and the ones that are above are really far to the right, creating this kind of bow tie shape. So the purple line is not the best trend line. It does show a negative association. It does actually hit 1, 2, 3, 4, 5 of the points, but it's not following along the rest of the points as well. So I would say the green line is the most reasonable trend line because it does say to explain, it shows the association of the points is the closest to most of the points and has similar numbers above and below. Okay, so we did a little bit of explaining there, but it shows why we chose the green line. So let's have you guys give this a try in your U-Try. Alright, so now we need to be able to create the equation to this trend line that all of the data points are following. So all you need to do is follow these 4 steps every single time you want to make a trend line. Notice step 1, it says identify 2 points on the trend line. The points that this red line identified were these 2 right here. If you notice, those 2 red points are actually not a part of the data set. You do not have to pick points that are already a part of the data, but it does make it a little easier if you just want to pick points that are a part of the data. Either way works. You can make up your own points, or you can choose from 2 points that are already plotted. So first thing we have to do, step 1, identify 2 points on the trend line. We did that. We have this one and this one. Second step, we need to find the slope between those 2 points. So recall the slope formula. Slope is equal to y2 minus y1 over x2 minus x1. So they gave us the 2 points, okay? They gave us what the coordinates were. Now we just need to apply the slope formula. So my slope is going to be 20 minus 40 over 2 minus 6. Again, if you switch these around, like if instead you write 40 minus 20 over 6 minus 2, you just switch the order on the top and the bottom, you should still be getting the same thing. 20 minus 40 is negative 20. 2 minus 6 is negative 4. A negative over a negative is a positive, and 20 divided by 4 is 5. So I'll just show you guys the other one as well. So if they're flipped around, we still get 40 minus 20, which is 20, and then 6 minus 2, which is 4. 20 divided by 4 is 5. So it really does not matter which way you want to actually do the slope, as long as they're in the same order on the top and on the bottom. So our slope here is 5. Now we need to plug into y equals mx plus b. If you recall from when we created y equals mx plus b's from 2 points, we started just by writing y equals mx plus b and then plugging in what we got for m into the m. So we have y equals 5x plus b. Now our last step, we need to actually figure out what the b is, what the y-intercept is. Don't just read it from the graph. Okay, don't just try to read it off of there. Actually calculate it using one of the 2 points, either this one or this one, that you picked for your trend line. I'm just going to use the first one I see, that 220. I plug in the 2 for x, I plug in the 20 for y. So I have 20 is equal to 5 times 2 plus b. 20 is equal to 10 plus b. And if I want to solve for b, I just need to subtract 10 from both sides. So I get that b is equal to 10. So the equation of this trend line is y equals 5x plus 10. Now, the reason why we have to do this, why we have to create the y equals mx plus b's, is because we're going to use those equations to help better our predictions. We're not just going to eyeball it anymore. We're going to plug into this y equals mx plus b when we estimate one of our approximations. So we found the y-intercept, that was our third step, and then we wrote the equation. So if you follow those 4 steps every time and reference this intro page, you should be fine. Let's look at example 2. It says the scatter plot suggests a linear association among the data. Drag the line to make the trend line that represents the data. That was when this was interactive, so since it's a video, I'm just going to draw a trend line in. And then we're going to write the coordinates of the 2 points and figure out the equation. Now again, you can either choose 2 of the points that you see, or you can make up your own points. I'm just going to choose 2 of the points that I see. Now I'm going to choose these 2 points very carefully. I want to try to choose 2 points where when I draw a line through them, there's approximately the same number of points above that there are below. I'm seeing that this point might be a good one and this one might be a good one because when I draw a line through them, okay, and I would highly suggest using a ruler for this. When I draw a line through them, I see 1, 2, 3, 4 above, and I see 1, 2, 3 below. That's relatively the same amount above and below. The line that you draw should also follow along the data points. So I'm going to use those 2 points that I circled. The coordinates of those 2 points, it looks like this first one is 3, 13. The second one, if I'm reading it correctly, it looks like 5, 19 approximately. And now we just follow the same steps that we had from the intro slide. So I'm first going to find the slope between these 2 points. Again, slope is equal to y2 minus y1 over x2 minus x1. If you didn't understand it on the intro slide, you have the x coordinate from the first point, the y coordinate from the first point, the x coordinate from the second point, the y coordinate from the second point, and now we just plug in. So I've got 19 minus 13 over 5 minus 3. Simplify that. 19 minus 13 is 6. 5 minus 3 is 2. 6 divided by 2 is 3. So the slope of our line is 3. So far, we have y equals 3x plus b. Now again, just choose one of the 2 points that you see above. Plug x in for x and y in for y. I'm just going to choose the first one I see. So 13 is equal to 3 times 3 plus b. So we have 13 is equal to 9 plus b. Now we need to solve for b. That means we have to subtract 9 from both sides. So now I've got b is equal to 4. So the equation of my trend line is y equals 3x plus 4. So I want you guys now to try this on your U-Try. All we're doing is creating equations of lines. So pick 2 data points or make up your own, find the slope, and use it in your y equals mx plus b. So on this last example, we're going to do the exact same thing that we did in example 2, only we're going to use our y equals mx plus b to make a more precise estimation. So first, take these points. There we go. Take these points and plot them down on your grid. Pause the video and then plot them down. Once you're ready, your graph should look like this. So now that we have our data points plotted, we need to pick 2 points to create our trend line from. Since these lines are relatively in a straight line, almost, I'm just going to pick 2 points that are already plotted. So how about that one and that one? Why not? Okay, we have our first point is at 3, 6, and our second point is at 9, looks like 7.5. So now I'm gonna calculate my slope. Slope is equal to y2 minus y1 over x2 minus x1. I have x1, y1, x2, y2. So now I've got 7.5 minus 6 over 9 minus 3. That gets me 1.5 over 6. Now, I don't want to mix decimals and fractions, but slopes should always remain a fraction. So what I'm going to do is I'm going to get rid of that decimal place by multiplying both the top and the bottom by 2, because I know that 1.5 times 2 is 3, which gives me a whole number on the top and the bottom, and it won't mix fractions. So I've got 3 over 12, and now it's easier for me to see how that can reduce. Both 3 and 12 can be divided by 3, and that gives me 1 over 4. So now so far, I have y is equal to 1/4 x plus b, and I'm going to take the very first point I picked and plug x in for x, y in for y. So I've got 6 is equal to 1/4 times 3 plus b. That gives me 6 is equal to 3/4 plus b. Now, if you don't want to deal with that fraction, you can clear it. Take the denominator and multiply everything you see by it, because it will cancel with that denominator. So 4 times 6 gives me 24. Then you have that 3 left over, and then you have to multiply the 4 times the b as well. So we have 4b. Now all I need to do is subtract 3 from both sides. 24 minus 3 is equal to 3 plus 4b minus 3. 3's cancel. We're left with 21 is equal to 4b, and then just divide by 4. For the y-intercept, you can keep this as a decimal. It doesn't need to be a fraction. The only thing that needs to be a fraction is the slope, so that you can see the rise over the run. 21 divided by 4 is 5.25. So the equation of my line is y equals 1/4 x plus 5.25. Now I'm ready to make some estimations in part C and part D. We need to estimate how much a movie ticket will cost in 2020. Well, years are on the x-axis, but it does say years since 2020, or 2000, excuse me. 2020 is 20 years from 2000. So we need to be plugging in 20 in for x. So now 1/4 of 20 is 5, and 5 plus 5.25 is equal to 10.25. So my estimation for how much a movie ticket will cost in 2020 is $10.25. $10.25 would be my approximation. Now we need to approximate, when did the average movie ticket cost $6.50? Well, ticket price is the y, so we need to plug in $6.50 in for y in our equation. So y equals, not y equals, we want to plug in for y. So we have, $6.50 in for y. $6.50 is equal to 1/4 x plus 5.25. So when we solve for x here, we first need to get rid of that 5.25. So we have 650 minus 5.25 is equal to 1/4 x plus 5.25 minus 5.25. We get, let's see, 125 is equal to 1/4 x. Now, whenever you want to clear a fraction, again, you just multiply by whatever's on the denominator. So if you multiply this side by 4, the 4's cancel, and you're left with just 1x. But you have to do the same thing to the other side. So we have x is equal to 5. So since x represents years since 2000, 5 years since 2000 would be about 2005. So my approximation for how much a ticket would cost in 2020 would be $10.25, and my approximation for what year a movie ticket costed $6.50 would be 2005. Now, your answers may be slightly different. Again, you need to know that. If you are a little bit off, like you did this problem yourself and you got 2004 or you got 2006 for Part D, that's okay. You're actually relatively close to the answer. These are supposed to be predictions. They're not supposed to be exact from person to person. So go ahead and give this a try in your U-Try. So that was our last lesson on learning how to construct and explain scatter plots. Today we focused on the construction part of y equals mx plus b for these scatter plots. And to be successful, we did draw a line of best fit by estimating 2 points that would go through these data points as closely as possible with an even number of points above and below. That was both example 2 and example 3. And then we also made predictions about interpolated and extrapolated points. That was mostly example 3. All right, if you have any questions, please let me know, and you may start your practice.